Human endocrine system. Endocrine glands are present in different parts of the body: pituitary, pineal, thyroid, adrenal, pancreas, parathyroid, thymus, and gonads are the organized endocrine glands in our body. In addition to these, gastrointestinal tract, liver, kidney, heart also produce hormones. 1. Hypothalamus. It lies at the door of the encephalon. It regulates many body functions. It contains several groups of neurosecretory cells which produce hormones. These hormones regulate the synthesis and secretion of pituitary hormones. The hormones produced by hypothalamus are of two types: the releasing hormones and the inhibiting hormones. Example, hypothalamic hormone called gonadotrophin releasing hormone, GRH, stimulates pituitary synthesis and release of gonadotropins. Somatostatin from hypothalamus inhibits the release of growth hormone from pituitary. These hormones originating in the hypothalamic neurons pass through axons and are released from their nerve endings. These hormones reach the pituitary gland through a portal circulatory system and regulate the functions of anterior pituitary. The posterior pituitary is under the direct neural regulation of hypothalamus. 2. Pituitary gland. Pituitary gland is very small, the size of a large pea seed, but it is a very important gland and it controls the functions of all the other endocrine glands in the body. It is therefore called as master gland of body. The pituitary gland is located in a bony cavity called sella turcica and is attached to hypothalamus by a stalk. It has three parts: anterior, middle, and posterior. Posterior lobe of pituitary is called neurohypophysis, while anterior and middle pituitary lobes are collectively called adenohypophysis. A. Anterior pituitary. 1. Growth hormone or somatotrophin hormone, GH or STH. The hormone stimulates body growth by increased anabolic activity, retention of calcium, synthesis of more proteins, enlargement of long bones, muscles, and visceral organs. Increased secretion produces gigantism, height about 2.15 meters, while deficient secretion produces dwarfism, height 1 to 1.3 meters. Excessive secretion of hormone in an adult causes acromegaly, increase in size of bones of hand, feet, and face. 2. Prolactin. Maternity hormone. It stimulates growth of mammary glands during pregnancy and lactation afterwards. 3. Thyroid stimulating hormone, TSH. It stimulates thyroid to produce and release its hormones. 4. Adrenocorticotropic hormone, ACTH. It activates adrenal cortex to produce its hormones. 5. Follicle stimulating hormone, FSH. It stimulates sperm formation in males, growth of ovarian follicles, and secretion of estrogen from them in females. 6. Luteinizing hormone. In females, the hormone stimulates ovulation and secretion of progesterone from corpus luteum. In males, the hormone is also called interstitial cell stimulating hormone, ICSH. It induces lay-dying cells of testes to secrete testosterone. FSH and LH hormones are collectively called gonadotrophins or gonadotrophic hormones. B. Middle lobe of pituitary. Melanocyte stimulating hormone, MSH. The hormone causes dispersal of melanin or pigment granules in chromatophores, causing darkening of skin. C. Posterior lobe of pituitary. It produces two hormones which are actually neurosecretion products of hypothalamus. 1. Oxytocin. The hormone stimulates uterine contractions during childbirth and milk ejection during sucking of infant. Oxytocin is also called birth hormone and milk ejection hormone. Milk secretion is under control of prolactin. 2. Vasopressin antidiuretic hormone, ADH. It is essential for reabsorption of water from distal convoluted tubules, and collecting ducts for producing concentrated urine. Deficiency of hormone causes disorder known as diabetes insipidus. It produces a lot of urine, more than 1.5 liters per day, at short intervals, resulting in excessive thirst and dehydration. At high concentration, the hormone raises blood pressure, BP, by causing constriction of arterioles. 3. Pineal gland. It is a small stalked body located on the dorsal side of forebrain. The gland secretes hormone called melatonin. It controls mood, sleep, regulates sexual cycle, body temperature. It also influences metabolism, pigmentation, the menstrual cycle, as well as our defense capability. 4. Thyroid gland. It is the largest endocrine gland, which is attached to trachea below larynx. It is bilobed or H-shaped. Thyroid secretes thyroxine. Iodine is required for the production of this hormone. The thyroid gland is composed of follicles and stromal tissues. Each thyroid follicle is composed of follicular cells enclosing a cavity. These follicular cells synthesize two hormones, namely tetraiodothyronine or thyroxine T4 and triiodothyronine T3. Deficiency of dietary iodine causes enlargement of thyroid, which results swelling of neck. This disorder due to hypothyroidism is called goiter. Hypothyroidism during pregnancy causes defective development and maturation of growing baby, leading to stunted growth. Cretinism, mental retardation, low intelligence quotient, abnormal skin, deaf mutism, etc. In adult women, hypothyroidism may cause irregular menstrual cycle, myxedema or puffiness. Due to cancer of thyroid gland or due to the development of nodules of thyroid glands, the rate of synthesis and secretion of the thyroid hormones is increased to abnormal high levels, leading to a condition called hyperthyroidism, which adversely affects body physiology. It also leads to protrusion of eyes or exophthalmia, high metabolic rate and leanness. Common salt is compulsorily iodized with Ki, potassium iodide, to provide required iodine to thyroid. Thyroxine controls basal metabolic rate, BMR. It determines the consumption of energy, tendency of the body to gain weight, physical activity, body temperature, heart, physical development, mental development, muscular activity, nervous activity, and sexual development. The hormones also support the process of RBC. It controls the metabolism of carbohydrates, proteins, and fats. Maintenance of water and electrolyte balance is also influenced by thyroid hormones. Thyroid gland also secretes a protein hormone called thyrocalcitonin, TCT, which regulates the blood calcium levels. 5. Parathyroid gland. 4 parathyroid glands are present on the back side of thyroid gland, 1 pair each in the 2 lobes of the thyroid gland. The glands secrete parathormone. The hormone maintains optimum level of blood calcium and phosphorus by reducing their excretion and mobilization from bones when required. Parathyroid hormone increases the calcium levels in the blood. PTH acts on bones and stimulates the process of bone resorption. It also stimulates reabsorption of Ca2+ by renal tubules and increases Ca2+ absorption from digested food. PTH is hypercalcemic hormone, that is, it increases the blood Ca2+ levels. Along with thyrocalcitonin, TCT, it plays a significant role in calcium balance in the body. It is essential for proper functioning of nerves and muscles. If sufficient amounts of this hormone are not produced, bones lose calcium and become soft. If the hormone is in large quantities, the muscles become very active and remain in contracted state, a condition called tetany. 6. Thymus. Thymus gland is a soft, pinkish, lobular structure located on the dorsal side of the heart and aorta. The thymus plays a major role in the development of immune system. This gland secretes a peptide hormone called thymosins. Thymosins play a major role in the differentiation of T lymphocytes, which provide cell-mediated immunity. The size is maximum during puberty, but begins to shrink and becomes microscopic in old age. Thymus is degenerated in old individuals, resulting in decreased production of thymosins. As a result, the immune response of old persons become weak.